We're surrounded by AI every single day, and a lot of the time, we don't even notice it. But as these systems get smarter and more powerful, this whole new world of threats is popping up. We're talking about the art of tricking the AI mind itself. So today, we're diving headfirst into the wild new frontier of AI security to figure out just how these systems can be manipulated. So, how do you trick an AI? It sounds like a pretty straightforward question, doesn't it? But, it's not always about writing some super complex code or smashing through digital firewalls. Sometimes the real key to cracking an AI, well, it's just knowing the right thing to say. Let's dig into how simple language can actually become a weapon.
And that really gets to the core paradox of AI today. Its biggest strength, the fact that it can learn and adapt on the fly, is also its single biggest weakness. I mean, think about it. Every cool new thing it can do also opens up a new door for things to go wrong. It's basically turned the whole world of cybersecurity into a completely new kind of battlefield.
All right, so first up, let's talk about what the experts call direct input attacks. Don't let the fancy name fool you. These are the kinds of hacks that happen right where you and I would interact with an AI, right at the user interface. I love this analogy. Think of it like walking right up to the AI's front door and trying to sweet talk your way past the bouncer. Okay, so the first and probably most famous technique here is something called prompt injection. This is basically the art of crafting a command, a prompt, that completely hijacks the AI. It makes the AI forget its original programming and just do what you tell it to do instead. It's really a battle of wills, a battle of instructions, and the attacker is doing everything they can to make their instructions come out on top. And just look at how ridiculously simple this can be. A command like this one, you're aiming it at, say, a customer service bot. This isn't hacking in the old school sense, right? You're not breaking code. You're just telling the AI to forget its rules and give you something for free. And the really scary part? Sometimes it's literally that easy. Now, a close cousin to prompt injection is a technique called jailbreaking. This is where you get really clever with your prompts to trick the AI into completely ignoring its own safety filters. You've probably seen some of these online. Things like the do anything now prompt, or DAN for short. These are classic jailbreaking methods designed to push the AI to talk about things it's not supposed to, or do things it's been programmed to refuse. But hey, these attacks aren't just limited to words. There's another method called input manipulation, and here the target is the AI's actual perception of the world. An attacker can add this almost invisible layer of digital noise to an image. To you and me, the picture looks exactly the same. But to an AI, that tiny, subtle change can make it see a stop sign as a green light. It's a direct assault on the AI's senses. Okay, so that's all pretty scary. How in the world do you defend the front door against this stuff? Well, it's all about layers of security. First, you've got output filtering, which is like a second security guard that checks the AI's response before you ever see it. Then, for really big deals, like deleting a file, you need a human in the loop, an actual person to give the final okay. And at the very heart of it all, you need really strict, well-written system prompts to build a strong wall between the AI's core rules and whatever a malicious user is trying to make it do. But look, not all attacks are that direct. They don't all come through the front door. Some are way, way more sneaky, targeting the very foundation of how an AI learns. This is a concept called poisoning. It's all about corrupting the AI's digital brain while it's still in training, long before it ever has a single conversation with a user. And there are basically two main ways to poison an AI. On one hand, you have data poisoning. Think of this like sneaking fake facts into the textbooks an AI is studying from. It learns the wrong stuff from the very beginning. Then you have model poisoning, which is much more direct. This is like performing brain surgery on the AI itself to fundamentally change how it thinks and processes information. To really get your head around the impact of this, just look at this example. An attacker could feed a cybersecurity AI thousands, maybe millions of examples where dangerous malware is labeled as safe. The AI just learns this as a fact. So later, when it's out in the real world and sees that same malware, it thinks, oh yeah, I know this one. It's totally safe. And it just lets the attack right through the gates. And this whole poisoning thing isn't just for creating security holes. It can also be used to inject all sorts of nasty biases into a system. By messing with the training data, someone could intentionally teach an AI to give unfair or discriminatory results for things like, say, job applications or bank loans. It's a really subtle but incredibly powerful kind of sabotage. So how do you fight back against poisoning? Well, it's all about making sure your data is clean. It's about data integrity.
Data sanitization is a big one. That's using automated tools to hunt down and get rid of anything that looks weird in the training data. And then you have tech like hashing and versioning, which basically create a unique digital fingerprint for the data. If even one tiny thing is changed, that fingerprint breaks, and you know someone's been tampering with it.
All right, so for our last section, let's talk about what happens once the AI is actually out there, in the wild. We're talking about operational issues. These are problems that don't come from a direct attack, but just from the messy, complicated reality of how these systems work and how they plug into everything else.
I'm sure you've heard about AI hallucinations, right? That's when the AI just makes stuff up, but says it with 100% confidence. A lot of the time it's just funny or weird, but it can actually be weaponized. An attacker could, for example, cleverly prime an AI to hallucinate a fake security flaw. That could send a company's entire security team on a wild goose chase, wasting tons of time and money on a problem that doesn't even exist.
Now, even the best AIs have safety guardrails built in, right? These are filters meant to stop them from doing bad things. But attackers are always poking and prodding at these defenses, looking for blind spots, searching for loopholes. It's this constant cat and mouse game where a really clever prompt might just hit on a magic combination of words that the designers never even thought of blocking. And this is where the risk gets personal and very real. Once an AI is hooked up to your other tools, I'm talking your email, your calendar, your company's entire database, a simple little prompt injection attack can suddenly become catastrophic. Think about it. An attacker could potentially trick that AI into deleting every single one of your files, or maybe sending scam emails to everyone in your contact list. The potential for damage is huge. Okay, that was a lot. We've talked about attacks through the front door, attacks on the inside during training, and exploits that pop up out in the real world. So let's pull all of this together and take a look at the big picture, the new security playbook for the age of AI. This really brings the whole battlefield into focus, doesn't it? For every type of attack, there's a defense strategy. You've got those direct attacks on the user input, and the defense there is better validation and filtering. Then you have the attacks on the training data, which are countered by making sure that data is absolutely pristine. When they try to jailbreak the AI's logic, the answer is stronger internal guardrails. And to stop those hallucinations, new methods are being created to tie the AI's answers back to real, verified facts, so it can't just go off and invent things. And all of this really leads us to the biggest question of all. Look, this isn't a problem we can just solve once and be done with it. It's a constant, never-ending race between innovation on one side and exploitation on the other. And as AI gets deeper and deeper into our everyday lives, the stakes of that race just keep getting higher and higher. The next huge vulnerability, well, it's always just around the corner, just waiting for someone to find it.